Hey guys, Mr. MathWiz here, just throwing together a short video on Lesson 2, which we'll be covering here soon. Sorry I didn't get it up sooner for you, but I'll try to make this a nice quick video to hit all the key points. So last week we talked about percentages and how you can turn a percentage into a fraction. So if we had something like 23%, we would turn it into a fraction, which would just be 23 over 100, right? And then if we wanted to use that to find information, so like let's say we wanted to know what 23% of, 23% of $70. If we wanted to know what 23% of $70 would be, we would create a proportion. We put 70 on the bottom because 70 and 100 both equal the original price, right? And then we would solve the missing piece, and that would give us 23% of 70 by taking the opposite corners. X would equal 23 times 70 divided by 100, and that would get us our answer, right? So that's how we figured out, and that's what we were working on in the last lesson, by turning the percentage into a fraction and then using our proportions to solve it. So in this lesson, we're going to keep on with the same idea, but we're stepping away from the proportion methods and with the butterfly method, and we're going to look at constants of proportionality, which we worked on a lot before. So what that's going to look like is basically, instead of changing the percentage into a fraction, we're going to be changing the percentage into a decimal. So this is actually way easier than it sounds. Some of you guys may already know how to do this. But in this case, as we said, 23% is the same thing as 23 over 100, right? Well, as you guys know, because I've said it over and over and over again, every fraction is also a division problem, right? So 23 over 100 is the same thing as 23 divided by 100, right? And if you divide 23 by 100, you can put it in a calculator, or if you know how to divide, if you know the tricks of dividing by tens, 23 over 100 becomes 0.23, okay? So that means that 23%, oh, sorry for the sloppiness there, 23%, in addition to being able to write it as a fraction like we did there, 23% can also be written as 0.23, or sometimes you'll see 0.23. That means the same thing. So every percentage can be written like that. All we really did, let me scroll down. All we really did here is move the decimal a couple places, right? So you can do this with anything. If I had 47%, it becomes 0.47. And the way I do that is I'm taking 47, and 47 has an invisible decimal point right here that you don't really see, right? Because we don't need it. But whenever you turn a percentage into a decimal, you're taking that invisible decimal point and you're moving it two places to right there. So that 47% becomes 0.47, or like I said, you might write it as 0.47, means the same thing, right? You're always moving two decimal places. That's the important part to remember. A very common mistake that I see when students are doing this is they'll see the 47 and this 0.47, and they'll assume that all we're doing is putting the decimal point in front of the number. That's not true. We're moving it distinctly, we're moving it two places. 1, 2, right? So that means that even if your percentage is less than 2 digits, like let's say the percentage was just 8%. If I turned 8% into a decimal, I'd be taking that 8 and I'd be moving the invisible decimal point two places still, right? So that means my new answer is it's not 0.8. A lot of people will put 0.8 and they'll be wrong. It's 0.08, okay? Because I moved it two places. 1, 2, right? And that's where the 0 came in. So always remember, when you're turning something from a percentage to a decimal, you're moving it two places. And the same thing would occur even if the number had 3 digits. Like let's say it was 123%, right? To turn that into a decimal, I'm still moving it two places. I'm still taking that 123, and I'm moving it two places, which puts it right after the 1. I get 1.23, okay? So changing a percentage to a decimal is super easy. You're just moving that decimal point two places. and you're always moving it 2 places. No more, no less. All right, so the reason that this helps us is that it lets us basically use this new number with our decimal points. This is basically a constant of proportionality. It's our unit rate, essentially. So if you think back on the last lesson, it allows us to do some really fun stuff. So let's say that you had to figure out what 37% of 75 was. The way that we worked in the last lesson, you would do 37% as 37 over 100. And then you would equal that to, I said 37% of 75, right? So 75 is our total. It's our original. So you'd write it on the bottom with the 100, because you have to keep the totals in the same row together. And then you have the missing piece up here, right? So the way we solved it in the last lesson is you would take x equals 37 times 75 and divide all that by 100, right? And that'll get you your answer, which I don't know what it is off the top of my head. Let's see here, 37 times 75 divided by 100 give you 27.75. So 27.75 is 37% of 75, all right? So if that was money we were talking about, and you were doing like a sale, 27.75 would be the amount that equals 37% of that $75. Okay, so that's how we did it based on the lesson that we did yesterday. I'm sorry, not yesterday, the last lesson. So the way we would do it with decimals is actually, in my opinion, way simpler. So I'm going to show you that real quick. 37%, if you write it as a decimal, you're moving that dot 2 places, right? So it becomes 0.37. So to figure out what 37% of 75 is, this is where it gets kind of fun, is you literally take that percentage as a decimal, that 0.37, because it's the constant of proportionality, and you're multiplying it by, that's not a decimal point, that's a multiplication sign. You're multiplying it by that 75. So 0.37 times 75, which was our original price. And, oh, I lost my calculator app. I must have closed it by accident. Here we go. All right. So if I take 0.37, check this out, and I multiply it by 75, I get 27.75. Same thing I got over here, right? 27.75. So I actually saved myself several steps. I saved myself a lot of work by turning it into a decimal point first and solving it. So that's the big idea here. If you have, I'm going to change colors. Let's go with purple. If you have a percentage, any percentage, and you know the original, you can solve it real quick and easy. So we talked about going shopping and how my roommates will ask me, hey, what's the cost of this? This $90 shirt is 60% off. How much does it cost, right? So what I'll do, the first step I do is, since it's 60% off, I want to know what the final cost is. So I'll do 100 minus 60, and I do that in my head. 100 minus 60 is 40, right? So if it's 60% off, then that means the final cost is going to be 40% of the shirt. So then all I have to do is turn 40% into a decimal point. So I move it 2 places. If I take 40% and I move it 2 places, that becomes 0.4, okay? And I'm also able to do that in my head. That's not too hard. So 0.4. So all I'm really doing is taking 0.4, multiplying by the original price, which I said in this case would be a $90 shirt. And then I would get the answer. So this part you might be able to do in your head, you might not. But that would give you, I'll just do it on here so you guys can see it with me. Where's the clear button? There it is. So 0.4 times 90 equals 36. So the final cost of that shirt would be $36. You see how simple that was? You turn the percentage into a decimal, and then you just multiply it by the original, and you've got it. All right, second part that I want to show you is also super simple, and that is how to figure out the percentage if all you have are the 2 values. So let's say that a friend of mine is willing to buy something that's $70, and they tell me, hey, I got it on sale for $50. And they feel like it's a really good deal, and I want to know how good of a deal they actually got, right? So if it costs $70, and they paid $50 for it. The way we did it before is you would write the proportion. You put 100, that was a sloppy 100. You put a 100 on the bottom, and you'd do the butterfly, multiply across, get your answer, just like we've been doing before, right? But actually a much quicker, simpler way to do this is just to divide 50 and 70. So this is going to be a little mind-blowing. Hope you follow along. So ignoring all that, we could go that route. You guys know how to do this, right? But instead, I'm going to take their original price of 70, the amount they paid, 50, right? And every fraction's a division problem, right? So I'm going to do 50 divided by 70. 50 divided by 70 would give me 0.7142, right? 0.7142. Well, remember how every percentage can be written as a decimal just by moving it 2 dots to the left? Well, you can also turn a decimal into a percentage by moving it 2 dots to the right. So 0.7142 is the same thing as 71.42%, right? So now, is that the amount that they saved, or is that the amount that they paid? Think about it. They paid $50. The original was 70. So remember your relationships. They have to stay the same, right? So since we calculated 50 over 70, and 50 was the amount paid, then the 71% would also be the amount paid. So I'm looking for how much they saved. I would have to take 100 and subtract that 70. I'll just round it to 71. 100, subtract that 71, and that'll give me 29% that she saved. All right? So all in all, you're finding out the same information you found out before when you did it with proportions, like over here, right? You're finding out the same information. You're just doing it differently. You were doing it with decimals instead of proportions. You might find proportions easier. You might find decimals easier. In my case, it varies depending on the problem, right? Some problems, it's really easy to do the decimal, especially if it's a direct problem where they give you the original and they just want you to find the sale, right? If you're trying to figure out what 20% off of 17 is, you just do 0.2 because 20% moved 2 places, right? And then I multiply that by 17, and that would give me my answer. So it's super quick and easy. 17 times 0.2. And there's my answer, 3.4, right? So in some situations, using this decimal, using the constant of proportionality, because remember, the number you're multiplying by your variable is always your constant of proportionality. So in this case, doing something like that, I find very quick and simple, much easier than drawing the proportions. But you can still solve the problem the same way with proportions. So I'm just teaching you multiple methods here. Use whatever you want to when you're solving word problems, but make sure you're familiar with both of them, because you may have questions on a test that asks you to recognize which formula works better for the situation, that sort of thing, right? So make sure you understand both, but when it comes to your own life and when it comes to word problems, you would use whatever you want to. All right, I'll stop this video now before it gets too long. Have a great day, guys. I'll talk to you later. Bye.